retrofitting of record reinforced concrete beam flexure using CIFRP rod and anchor bolt. Our article basically consists of sublimate or testing a total of 4 simple supported beams under of point load. All beams were primarily designed to fail under bedding. A normal reinforced control beam was evaluated and compared with the others, driven things of ultimate load capacity, deflation, and ductility.
For this process, similar normal concrete was selected and prepared for the 4 beams with an average compressive strength of 40 MPa at the age of 28 days. Average compressive strength was calculated based on BAs and EN using 150 100 mm size cubes. To complement, we use steel bars with CFRP characteristic, bolt, anchor, and material coatings. In this experiment, a steel reinforcement of age 10-12 mm with an elastic limit of 520 MPa was used. The maximum tensile strength for all the bars was 570 MPa, with Jones method equivalent to 200 GPa. In addition, 3 CFRP rods with a length of 2000 mm were used in this study, and from this we were able to deduce that the union between the old and new concrete requires special attention. Therefore, it is recommended to use concrete without chinkers but with a high coating.
Results: corrosion of steel bars due to accelerated corrosion. Corrosion in tension bars started when the fluorine beams were exposed to a corrosive environment consisting of a solution of sodium chloride. This accelerated corrosion causes cracks in the tension part of arch beams. Moreover, it can really affect the quality of concrete. Loading analysis. Deflections. Corrosion causes a reduction in the stiffness of steel reinforcement, which causes the beam to fail faster. On the other hand, the load capacity of the repair beams may be affected with using CFRP rods, since the beam repairs with a CFRP B03 rod demonstrated a breaking load of 121.848 kN with the increase of 29.03% at breaking load compared to unrepaired corrode beam. Regarding deflections, the use of our CFRP rod cannot effectively increase the maximum deflection of the repaired corrode beam because there was only a small improvement, 8.12% in the final deflections compared to an unrepaired corrode beam. By the conversely, if multiple CFRP rods are used, there is a significant increase in the maximum deflections of the repair beam.
Ductility. Due to that low modulus of elasticity of the CFRP rods, a higher ductility index was achieved in the repaired beam. Coating on the top face of concrete. Using the short system resulted in thicker crack in the cross-sectional height of the reinforced beam. Therefore, the load was distributed over a large increasing cross-sectional height. This remarkable reduction is the complete strength of repaired beam, reveals the merit of the new repair system. Failure mode and cast pattern. Control beam by Seal 1 and unrepaired corroded beam by Seal 2 charity time failure mode, but being only developed binding during testing and the failure was due to the formation of the steel reinforcement intention.
However, there are more benefits that the implementation of CFRP brings demonstrated by the experimental study. The beams repaired with CFRP routes and anchor bolts and grids utility. Therefore, it is of shown that the implementation of CFRP is very useful, since with the implementation of system it is much more difficulty for sudden failures in the structure to be generated.
They are very important and easy to control such an inconsistency. However, there are more benefits that the implementation of CFRP brings, demonstrated by the experimental study. The beam repair by CFRP roar and anchor bolt angular ductility. Therefore, it is shown that the implementation of CFRP is very useful since with the implementation of system, it is much more difficult for sudden failure in the structure to be generated.